So for the same data as the previous example, advertising expenditure and weekly sales, now we're going to see how to set up a model like this. So we need to first do a transformation. What we're going to do is we're going to take natural log on both sides. When we do the natural log on both sides, this is what you will get. So ln of y, then here ln of alpha is the first term, and then plus the power becomes the product. So you just bring down the power, beta sub 1, and then you take a logarithm of x sub 1, and then here again plus ln of error. Now this can be rewritten as follows. Replace ln y as y star, ln alpha as alpha star, and then ln of x sub 1 as x sub 1 star, and ln of error is e. Okay. So now for y we need ln of y, for x we need ln of x. So we have to set that up. So Excel offers the function ln. So ln of sales gives us the natural logarithm of sales, and then ln of advertising will give you the natural logarithm of x here. Now copy that. Okay, so now we have the necessary transformed columns. Okay, so now we have only one transformed x variable, so we need a column for that and one column for y-intercept. So that's it. So now we do linest and make sure that we use the transformed columns. So transformed y, comma, transformed x. So you can have 2 or 3 more columns as transformed x's. In this example, we have only one column of transformed x. Comma, comma 1, close parenthesis, Control Shift Enter. So now we have the output. Now how are we going to use this output in a way that we get forecast for y? So you have to be careful. Okay, we have to transform everything back. So here alpha star, the estimate for alpha is a, so a star is that, the y-intercept. Okay, now beta sub 1 is not transformed, it is just simply beta sub 1, so there is no star for that. Okay, so that would be this. All right. So now ln of a, so a star is actually really ln of a, right? Ln of a being the estimate of alpha. Okay, so a is going to be exp of a star. So that's the reverse of ln. So if you did exp of a star, so that will give us the estimate for alpha. Okay, so then our prediction equation, you can use a and b here and then x sub 1. So it will be like y hat will be, so our y hat is going to be, okay, 597.13. Okay, that's the a value, this is the estimate of alpha. And then we have x sub 1, the advertising expense, to the power of beta, which is 0.095. Okay, so let's make that superscript, and x sub 1 would be a subscript. Okay, so that's our prediction equation. Okay, you can also do a prediction equation like this. Okay, you can first, so here we are going to y hat directly. Or if you use a linear function like this and find y star, okay, after finding y star, then you can reverse, at that point you can reverse the logarithm transformation by doing exp of y star. So either way will give you the correct answer. So the second method is to, instead of doing this, okay, you can also do, instead of finding y hat directly, you find y hat star. And y hat star will be 6.392, that's our A star. Okay, so that's alpha star's estimate, plus B, which is 0.095 times x1 star, x sub 1 star. Okay. Now if you do it in this fashion, then you have one more step. So you have to take that, so your y hat will then be, if you do it in this fashion, I'll put it here. If you do it in this fashion, then you have to undo the transformation as the second step. Okay. So if you take this approach, you do the untransforming. Okay, you take the reverse transformation from A star to simply A, and then you use this function and you get y hat directly. But if you don't do the untransformation of A star into A and you simply want to use A star and B1, then you will get only y hat star. And you have to undo the transformation as a second step. So let's set up the prediction values for all the three models here. Model 1 being the linear function, model 2 is the quadratic function, and model 3 is the transformed function. And we will look at how to do the prediction in each of those three cases.